Okay, so this lesson we're modeling with quadratic functions, and this is going to look a lot like when we did linear regression with the linear functions. So we're going to be using our calculator to do this. So problem 1, it says a parabola contains the points 0, 0, negative 1, 1, and 1, 5. What is the equation of this parabola in standard form? Use quadratic regression on your calculator. So the steps, again, we want to select stat, edit, put L1. In L1, we're going to use our x values. L2 will be our y values. Then you go back and select stat, and this time we're going to do calc 5, quadratic regression. So my ordered pairs here are 0, 0, negative 1, 1, and 1, 5. So this will be my L1, and this will be my L2. So what we'll do is we'll start with stat, hit enter. If you have anything in either of your lists, you want to highlight your list and hit clear and enter. Don't hit delete, okay? So that's super important. I'm going to put in my x values, which had 0, negative 1, and 1. And then we'll put in the corresponding y values, which were 0, 1, and 5. Once those are in, you're going to hit stat again, go to the calc menu, and you want to hit number 5, quadratic regression, and you can just enter through the whole list, and it'll calculate, it gives you your A, your B, and your C. So our equation is y equals 3x squared plus 2x plus 0. So we'll write that out. Whoops. Y equals 3x squared plus 2x. Now for problem 2. Here we have a softball pitcher, and we're trying to see if the ball will hit the catcher's mitt, which is at the ordered pair 0, 2. So I'm going to find the regression line using just the 3 points they give us, 28, 38, and 46. Okay. Once again, I'm selecting stat. I'm going to hit edit. We'll clear out our list, so highlight each one and hit clear enter. And then type in your ordered pairs. So we had 20, 30, and 40 for our x values. And then in the y values, we had 8, 8, and 6. And now stat, calc, pick number 5, quadratic regression again. And there is your equation, y equals negative 0.01x squared plus 0.5x plus 2. So here, to finish off the question, does it go through the 0.02? It sure does, because if you put zeros in for your x's, you're going to get the ordered pair 0, 2. So the answer is yes. That ordered pair is on the quadratic. Okay, next problem here. The table shows the meteorologist predicted temperatures for a full day in Baltimore, Maryland. What is the quadratic model for this data? Use quadratic regression on your calculator. One thing you want to know is for your L1 list, you're going to do 8 a.m., 11 for 11 a.m., but then switch to military time. 2 p.m. is 12 plus 2, or 14. 5 p.m. is 12 plus 5, or 17. 8 p.m. is 20. And 11 is 23. So this will be your L1 values, these will be your L2 values, and you're going to put them in your calculator just like we've been doing, quadratic regression, and when you do that, you're going to get, for your model, negative 0.16x squared plus 5.14x plus 21.60, rounding to the nearest hundredth. And so it's very similar to what we did with problem 1 and 2, but now it says use your model to predict the high temperature for the day. At what time does this predicted high temperature occur? And what we're going to do is we're going to put this into our graphing calculator, we're going to graph it, and we're going to find the maximum point. So I'm going to show you what that looks like. So up at y equals, I'm typing in negative 0.16x squared plus 5.14x. And then plus 21.60. Okay, now if you pick your standard window, you're not going to see everything that we want to see. We want to see the maximum. So I'm going to go to my window, and we're talking about daily temperature and x being our hours. So I'm going to set x max to 24. That'll give me a full day, 24 hours. And then y max, let's just set it up as a max of 80 degrees. So let's see what happens here. Now I see the progression of the temperature throughout the day. I'm going to go to second calc and select maximum number 4 and answer the questions. Left bound, I just need to be on the left-hand side of the top of that curve, hit enter. Right bound, then I need to move my cursor to the right side of the top of the curve, hit enter, and then guess, hit enter again. So I get an X value of 16, which is 4 p.m. with a temperature of 62.88 or 63 degrees or 62.9 degrees. So at what time does the predicted high temperature occur? It occurs at 4 p.m. and at 62.9 degrees, because the ordered pair we had for that max was basically that. This is 4 p.m., 62.9 degrees. All right, that's it. Good luck.